Hello everyone, welcome back to my another video. So in this video I have taken questions on D&F block elements. Let's see all those questions and try to figure out the right answer. So the very first question is like heating of K2Cr2O7 and KMnO4, and it has been given that A, B, C, D, E and F, the increasing order of molecular weights, and you need to find the incorrect statement. So what's more important over here is like the products of heating products are important. So if I talk about heating of K2Cr2O7, it will be giving you K2CrO4 plus Cr2O3 plus O2. And for DEF, if I talk about heating of KMnO4, so it will be giving you K2MnO4 MnO2 plus O2. Now the thing and all, if you can know the balancing, okay, then there is no issue with the first one. It's like 3 by 2, so this will become twice, and this will become like single only, and this will be like 3 by 2. But for the second one, you will be finding that K2MnO4 will be there as such, like there will be 1 mole, MnO2 is also 1 mole. So in order to figure it out between D and E, many students will commit a mistake. They will be thinking like, why I am not taking MnO2 as D and K2MnO4 as E. Okay, so for that thing, this information is given. Okay, so if you know this information, you will be easily able to segregate. Okay, and if that would be the case, then yeah, okay, K2MnO4 is D, MnO2 is E. So in a hurry, most of the students will commit a mistake, and that will be the deciding factor in your rank also. So now you have got A, B, C, D, F, and let's try to figure it out. Oxidation state of central metal atom are same in Agra as well as in Delhi. So if I talk about like Agra, then it will be like +6 chromium. And for Delhi, it's like K2MnO4, that also is +6. Then this is correct. This statement is correct. But what you need to find over here is the incorrect statement, right? Now the second one, molecular weight C and F is same. So if I talk about C, it's like O2 only, and F is also O2, so this is also correct. Molecular weight of E is greater than that of B, so if I talk about E, then it is MnO2, and B is like Cr2O3. So it's quite obvious, like Cr2O3 will have more weight than MnO2, so this statement is wrong, and that is what you need to find it out. So for this one, the incorrect option is Calcutta. And let's talk about option D also. Color of B and D is almost the same. So if I talk about D, then D was your K2MnO4. Its color is green, and Cr2O3 is also green. So yeah, that's true. So this is what, like, you will be getting questions of the compounds associated with D block elements, important compounds. You must be knowing all these informations. Now, the second part is quantitative conversion of K2MnO4 into KMnO4 cannot be carried out, right? So there are 4 options, and it's about it's a very important reaction of MnO4 -2. We know that MnO4 -2 only when we are following some different steps, then there will be a formation of MnO4 minus, right? So in the presence of acidic medium, it will be taught to you guys the issues and all that happens with MnO4 -2 is in acidic medium it furnishes along with MnO4 minus MnO2 also. So if I talk about quantitative conversion, so in this case, a decent amount of MnO2 is also there, that will be reducing the percentage yield of KMnO4, right? Whereas in the other cases, it is like K2MnO4 in alkaline medium. Okay, it's fine, decent amount. You'll be getting KMnO4 in good yield for this one. By chlorine in alkaline medium, you will be getting it in good yield. Through ozone also, you will be getting it in good yield. So just because you have K2MnO4 in acidic medium, so because of the furnishing of MnO2, good yield will not be there. So Agra will be the correct choice for this one. This is a kind of question which is there in the module of every coaching institutes, but this can be asked in the exam in this fashion. Okay, now the third one is, which of the following cannot reduce KMnO4 leading to its decolorization? So if I talk about KMnO4, then it's a strong oxidizing agent, and it is saying like acidified, which means you have acidic medium. So if it's a strong oxidizing agent, it will be oxidizing the one which is in front of KMnO4. So if I talk about SO2, then over here sulfur is +4. So KMnO4 oxidizing sulfur, yeah, sulfur can go from +4 to +6, then this is correct. There is no issue. Regarding H2O2, if I talk about, then H2O2 can act as both oxidizing agent as well as reducing agent. And this might have been taught to you guys in redox also. So over here, if I talk about H2O2, of course, KMnO4 is the oxidizing agent. Then H2O2 has to be a reducing agent. And yeah, that makes sense also. Like if you have acidified KMnO4, then H2O2 in acidic medium, okay, will be furnishing O2, right? So this is also correct. There will have reactions. Now FeSO4, again, it makes sense. It is like +2, so it can go to +3. So reaction will be there. But for the fourth one, if I talk about Fe2SO4 whole thrice, then in this case Fe is +3. So further oxidation of Fe won't be there, right? So if won't be there, which means KMnO4 will not be reacting with Fe twice, SO4 thrice. So right answer is Delhi. Then it is in accordance with the previous question only, like KMnO4 I have used, right? Now in this K2Cr2O7 is there, so it is also one of the strongest oxidizing agent. You need to figure it out, the incorrect statement associated with this. So the first part is like you have I minus, so you know that I minus will be going to I2 when there is a strong oxidizing agent in front of I minus, so that makes sense. Second one is like again estimation of Fe+2. So we discussed it in the above question also, like Fe+2 was going to Fe+3. So it is possible when you have oxidizing agent in front of Fe+2. Now inside acidic medium, we know that K2Cr2O7 will be furnishing chromium +3. And if it is like +3, then n factor of K2Cr2O7, it has been taught to you guys in redox also, that is equal to 6. So normality is equal to, must say, molarity into n factor. So if I talk about molarity, then it will be like normality by n factor, which is 6. So all the three options looks pretty fine with respect to K2Cr2O7. And if I talk about the last one, it's ammonium salt. This is very important. It is there in your module also. So if I talk about the ammonium salt of K2Cr2O7, then that is like NH4 whole twice, Cr2O7. It is there in comprehension. Okay? So the product is very much important. You will be getting Cr2O3 along with N2NH2O. So this reaction it's pretty fine. It will be furnishing Cr2O, O3. But the thing over here which is quoted is endothermically. Actually, this is a highly exothermic reaction. It is not indo. It is highly exothermic. And it also makes sense because over here intra, or you can say internal redox is taking place. If I talk about this ammonium salt of chromate, then over here you will be finding that nitrogen is in -3. So nitrogen is going to, from -3 to 0. And if I talk about chromium, then it is going from, +6 to +3. So it's the same element, it's the same compound in which one of the element is oxidized, another element is reduced. It's a internal redox which is happening, which means it will be like highly exothermic to carry out this phenomenon. So this is what you must have to be absolutely careful with respect to the reactions and all that has been taught to you regarding all those minute informations. If you have it in your mind, then it will be very easy for you to solve questions. Now, if I talk about the fifth one, transition metal cations are more prone to complex formation than S block and P block cations. What will be the responsible factor for that? So over here, complex formation, you know that if you will have a central metal atom or ion, then they will be taking electrons from the ligand. And I believe like your coordination also has started, so you must be knowing that ligand will be giving its lone pair or electron pair to central metal atom. Why the central metal atom and all is taking electrons from the ligand is because the central metal atom have empty or it has like partially filled d orbital. So if that would be there, then ligand will be giving its electron to central metal atom, right? And central metal atom is taking it. So if somebody is taking electrons, then I must say like that species will act as a Lewis acid, right? So that is like because of the availability, that complex formation is there. I must say like the interaction between the central metal atom and the ligand has to be strong, because if that interaction is not strong, there will not be having more strong complex formation, which means if I talk about the option number D, weaker nuclear attraction, then that also will be wrong, because instead of weaker, if it would have been stronger given, then stronger would have been correct. Now, a lack of variable oxidation state, if I talk about, then this is not true that the transition metal atom is having lack of variable oxidation state. In fact, variable oxidation state is one of the important physical properties. So this is wrong. And pairing of all d electrons, we know that there are many transition metals which have unpaired electron. So this is also wrong. And the last one was like weak was given, so it will be wrong. So right answer for this is Agra. Now for number 6, if I talk about, this exactly resembles to J advanced question in the year 2020, which I have given to you guys also in the previous video of D block element, the very last question, question number 8. So over here you have acidified dichromate solution that is reacting with hydrogen peroxide to produce a deep blue colored compound A in the presence of an organic solvent. Over here, the moment when blue colored compound is coming, you have been taught like you must have to think about CrO5, that is blue butterfly, right? So you have been told, or you have been taught also, like CrO5 is unstable in water. So since CrO5 is unstable in water, it will decompose, you know. So that's what it is written over here also. This compound is unstable in aqueous medium and decomposes to form another compound B. So if CrO5 is unstable, it will be furnishing Cr2O3, guys. So this is your compound number B. Okay, this is your compound B, this is your compound A. Anyways, the bluish species A can be extracted using dimethyl ether to form a adduct C. I've told you guys, like adduct means the product which is formed because of addition and all. So if you have a dimethyl ether, if I talk about C, anyway, C has got nothing to do with this question. But yeah, for information based, CrO5 dot C2H5 whole twice oxygen, right? So this is your compound C. But it has been told like compound B ka, you need to find the magnetic moment. So over here chromium will be there in its plus 3 oxidation state, and the moment when I'm saying plus 3 oxidation state, it is like D3 configuration, which will be equal to 3.8 Bohr magnetron. And in J advance, when this question was asked, over there amyl alcohol was used as a solvent, right? Now 7th one is like there was some printing mistake, so let's leave the 7th one. 8th one is from lanthanoids. If I talk about lanthanoids, then yes, they are highly electropositive and strongly basic. And if that would be the case, then first and the second options are pretty correct. But you need to find the incorrect one. The important thing inside lanthanoid is the nature of cerium plus 4. Now, if I talk about cerium plus 4, then cerium plus 4 to cerium plus 3, if I talk about reduction potential, okay, then that comes out to be like 1.61 volt, which means very high value of reduction potential, so a strong tendency to gain electron. So it acts as a strong oxidant. Yes, that's true. And the last one is like all tripositive lanthanoids are colored. That's not true. If I talk about lanthanum plus 3, it's like F0. If I talk about lutetium plus 3, then it is like F14. They are colorless because of no FF transition. So since there is no FF transition, so there will have no color. So incorrect statement for this one will be like Delhi. Now, for the 9th one, actinoids exhibit great number of oxidation states than lanthanoids. So what would be the probable reason for the same? There is a similarity between 4f and 5f orbital in the angular part of their wave function. If I talk about option B, actinides are more reactive than lanthanoids. That makes sense that. But over here with respect to this greater number of oxidation state, this is not at all correct. The reason over here with respect to greater oxidation state is like if I talk about actinoids, then it will be like 5f. And if I talk about lanthanoid, then it will be like 4f. 4f is like more closer to the nucleus compared to 5f. Over here also one point is written, the 5f orbital are more buried than 4f orbital. And over here in C, 5f orbital extend farther from the nucleus than 4f orbital. So C is correct, because if 5f is very much far, so it will be very much easy to take the electrons and all out. And actually C and D is like opposite of each other. 4f orbitals are more closer to the nucleus. Buriedness means orbitals are closer to the nucleus, and if orbitals are closer to the nucleus, they will be like less available for bonding. So right answer for this one is Calcutta. Now if I talk about the 10th one is like you need to find the stability order of oxidation state given for the metal cation. What you need to understand over here is you cannot take the help of only electronic configuration all the time. Reduction potential, hydration energy also plays a very important role. So if you are only thinking about electronic configuration, then you will be wrong. So in the first case, if I talk about Mn plus 2, then Mn plus 2 is like 3d5, and Mn plus 3, then it is like 3d4. So if I talk about for this case, half filled is more stable than partially filled, then this statement is correct. It has to be the other way around, Mn plus 2 rather than Mn plus 3. Now for the second one, over here hydration plays a very important role. If you are missing out, the hydration will apart, and if you will try to answer like the way you have answered for the first one, then it will be wrong. So over here if I talk about Fe plus 3, then that is like D5, and Fe plus 2 is like D6, but still Fe plus 2 will have more hydration. And if Fe plus 2 will have more hydration, so because of its small charge, the order and all will be like Fe plus 2 is greater than Fe plus 3. Now the third one, if I talk about chromium plus 2 and chromium plus 3, it makes sense. Over here, if it is chromium plus 3, it's a D3 system and it's a D4 system, right? So yeah, you can say like chromium plus 3 is greater than chromium plus 2. The reason being over here is like splitting of orbitals you can think of. Now the next one is cobalt plus 2 and cobalt plus 3. This is also very, very important. Cobalt plus 3, if I talk about, then it's a strong oxidizing agent in aqueous solution and is unstable also. And cobalt is more stable. Basically cobalt plus 2 is more stable. Okay. So the answer and all would be like the other way around for this one. Cobalt plus 2 greater than cobalt plus 3. One more application based on cobalt is there in the upcoming questions. Now for the 11th one, again it's a similar kind of reactions, right? You do understand, like you have MnO4 minus to Mn plus 2, then you have Mn plus 2 to Mn plus 4, right? And then you have MnO4 minus to MnO2. So these all conditions are like, if you can recall it, like band 153 for KMnO4, you will be able to figure it out. That key Agra is the correct choice for this one. Now the next one, question number 12. Over here student will find that since correct is written in bold, so they will be marking the correct one, but they have to be utmost cautious with respect to this not. So not every time you will be finding that incorrect is written in bold. Instead it can be framed in this fashion also. So you need to find the incorrect sequences. So basic nature, if I talk about for metal oxides, it has to be like lower oxidation state will be more basic, and if lower oxidation state is more basic, then the order and odd should be like MO, M2O3, MO2, and M2O5 is pretty correct, but you need to find not correct, right? Now increasing order of oxidation state, so it's like the some misprinting and all is there. You can say like increasing order of highest oxidation state makes sense. So scandium is like plus 3, vanadium plus 5, chromium plus 6, manganese plus 7. So that is also correct. Whereas increasing order of magnetic moment is like you have got D5 system, guys, you have got D4, you have got D3, and you have got D1. So we know that higher the number of UPE, higher would be the magnetic moment. So this order is not correct. Whereas for the last one, decreasing order of atomic size, you see physical properties size as you move, from left to right, it decreases. So scandium is more than titanium, titanium more than vanadium, and then chromium. So this is also correct, but you need to mark the incorrect one. So Calcutta is the correct choice for this. And the last one is exactly resembling to that of question number 10. So you need to again find the incorrect statement. Chromium plus 2 has strong reducing character. So if I talk about chromium plus 2, then it will be giving, chromium plus 3. So it's a stable configuration, right? Easily oxidized, strong reducing agent. This is what I have discussed in the above problems also. Mn plus through Mn plus 3 has strong oxidizing character. So Mn plus 3, say Mn plus 2. So it is going from D4 to D5. Makes sense, yeah, makes sense. Then cobalt plus 2 stable, but it is easily oxidized in the presence of a complexing reagent. So if I talk about cobalt plus 2, yes, it is stable, but it can go to plus 3 also. And when strong field ligands and all are coming like ammonia, ठीक है, तो दरअसल अमोनिया तो उसको वहाँ नहीं बोलते, we are saying it to be like amine. So in this case it forms a complex CONH3 whole 6, right, plus 3. So in this case cobalt plus 3 is stabilized because of the complex formation. So this is also true. But for the last one, this very much important. We know that ki copper plus 2 changes to copper plus 2, sorry, we know that ki copper plus changes to copper plus 2 plus copper. But the thing is, it is situation specific. ठीक है, conditions are very much important. It's not like copper plus can disproportionate all the time. Over here, if I talk about CuCl, then it's a sparingly soluble salt. And if it's a sparingly soluble salt, when you are putting excess of water, CuCl won't be furnishing copper plus. And if it won't be furnishing copper plus, then disproportionation won't be happening. So this is very, very important. Over here, disproportionation in excess of water. Since CuCl is sparingly soluble, it will be there as such only. And if it will be there as such, then Delhi is the incorrect statement for this one. So that's all from today's video. I believe like whatsoever has been taught to you in D block, I have given you the proper feel of everything, right? I will try my level best to put more questions based on the topics that will be taught to you. Till then, stay connected with me over Telegram. Put a like, subscribe the channel, and share this video. Okay? We'll meet again in the next video with some important topics again. Till then, take care. Bye-bye.